So all of this is based off of the graph of y equals x squared. There we go. That's what if you went back to your first page of this, we graphed this yesterday with our little table. And that graph, again, just looks like, I'm going to want all these in here. So let me get this guy ready. So I'll get rid of all of these. Clear. Clear. And then clear. So that's our parent graph. The parent graph meaning the one that everything else is going to be based off of. That's the one that we're moving around, we're shrinking, whatever. So what we're going to do today now is we're going to take this graph here, and instead of this being just an x squared, you can see what we're going to do right here. We're still going to have your y. We're still going to have this squared term. We're still going to have an x here. But instead of just x squared, you're going to see this minus h term. And the question is sort of, what do you think is going to happen? So if you kind of form a hypothesis in your head, how would that impact our graph at all? That's what we're going to explore here in this table. What we do know right now, so don't necessarily write this on yours, we do know the number in front of it shrinks it, makes it more narrow, makes it wider, up and down. That's what that number in front does. So now we're just kind of exploring what would happen if instead of an x, let's say maybe we have like an x minus a 2 squared. How is that going to impact some things? All right, and that's what we're getting at with these problems. So in your table, that's what we're going to do. So our quadratic function, just a bit, instead of the y equals x squared, so we're still going to have this. So there's our x squared. What we're now going to do is subtract. So if we look back up here, we're going to subtract whatever value of h I give you. In this problem, your value of h is going to be a 2. So we're going to put x minus 2 quantity squared. And then what we want to know is, well, how does that impact our graph? What's that going to make our graph do? So if we go to the calculator, if I now enter that, here's again the original. So the original one is blue, and then we'll see what happens when we do the x minus 2. So if I do x minus 2, and then square that thing, this will be red, you see here, so the red one will be the new graph, and watch what happens. So the blue one is the parent graph, it's the original one. We see our red one. Write down what just happened. There's nothing terribly deep right here that you can't just look at and write down what just happened. So what happened to the blue graph in order to create the red graph? Okay, pretty simple. And Cam, what are you going to have us write down? Good. I love the word shift because that's exactly what we would say. It's a shift. And by over, did you mean like up, down, left, or right? Right. Good. So this shifted over. And then look, remember we talked about the word vertex yesterday? Let me see if I can make this bigger. I don't know if I can. Notice how the vertex is at the point 0, 0. We moved it over to here's 1, here's 2. If I ask you what that vertex is right now, it's 2, 0. So we shifted it over, is what Cam said. We went from a vertex of 0, 0 to a vertex of 2, 0. So now let's write this down. So for this one here, it shifted. And then I asked Cam specifically, and that's to the right. So it looks like night with my beautiful handwriting there. That should say right. So we shifted this to the right 2 units. And that the word we talked about yesterday, the vertex went from 0, 0 to 2, 0. All right. So let's put that in here too. So we'll say our vertex, and we'll write it like this. So we went from 0, 0, and we moved it to 2, 0. Not a coincidence then. Notice what our value was. See how it was a 2? And we moved it right 2 units. So let's see if we're on the page here for this one. We would now do x minus 3 squared. So if we were to guess what's going to happen, you can guess. Let me show you one time, just to make sure we know. So let's go to this one. Have something in your head what you anticipate seeing right now, and then see if what you anticipate happening is what actually does happen. And if it does, then you're kind of understanding this little rule. So here we graph. All right, that's the black one. See how we got shifted further to the right? Notice where the black one's vertex is. We were at 1, 2, 3 is that vertex. So that got shifted to the right even more, got shifted to the right 3 units. So that's what we're going to put here. It gets shifted right 3 units. And our vertex, the original one now, which was 0, 0, now got shifted over to 3, 0. So we're still getting to know each other. We all appear to be fairly bright, young 14, 15, 16-year-old gals and girls, or guys and girls. Tell me what's going to happen here. So let's write this one. And then I think we're all good enough to tell me what's going to happen in this third one if we were to graph it. All right, Bisher, I saw your hand up first. What do you anticipate happening to this? Confirm this for everybody. Good. It's going to shift to the right 5 units from the original one. And the original one had the vertex of 0, 0. So if we're going to go 5 units to the right, like Bisher said, our new vertex would have been 5, 0. I don't have to graph it. That's exactly what happens. I promise if I graphed it, that's what would happen. Okay? So now, this one, a little different, similar but different. Remember what we're doing for the h is a negative, for whatever h value I give you. We're always doing x minus, and then whatever your h value is, that's what we're plugging in. Okay, so just going back up to here, we're going to plug in h after the minus sign. So in this problem, if your h is a negative 1, we would still have the x minus, but now what we would have is x minus a negative 1. You don't necessarily have to show those double signs. I wanted you to see that though, because we should then hopefully understand then that double negative really turns this into a plus a 1. So before I graph it, hopefully you're using a pencil, write down what you think is now going to happen now that we have an x plus a 1. And then I'll show you on your calculator if you're correct, on my calculator if you are correct. Anybody want to wager a guess? Cam, go ahead. All right, so Cam is hypothesizing that we're going to shift left 1 unit. So let's see if Cam is correct. Decent chance he is, or I probably wouldn't have written it down. So let's go down to the 4th one. And we ultimately had x plus a 1 because the h was a negative. We're going to square that. This one will be purple or pink, whatever color you think that is. And was Cam correct? Did that get moved to the left 1? Yeah. All right, good. So what that would allow us to do is to then say that our vertex has moved from 0, 0 to now a negative 1, 0. Which then hopefully prevents me from having to fumble around with the calculator on the computer here. If we go here now and we do x minus h squared, and this h is now a negative 4. If we get this x to ultimately be an x plus a 4 quantity squared, we would then hopefully know this is now going to get shifted left 4 units. So we take our vertex from 0, 0 to negative 4, 0. All right. Last one, we don't necessarily have to go through all of it. This would just be x plus a 6 squared. That's going to move us left. So now, to remember this, because even some of my calc kids and older people, as we get through this, get these mixed up a little bit. It's sort of counterintuitive now that we see these. Notice how when we have a minus sign here, when we actually have an x minus a number, that's going to shift us to the right. And if we have these being, do this in red here, if we have these being a plus sign, that actually shifts us to the left. Almost kind of the opposite of maybe what you would think when you look at these equations. All right. So you can summarize that if you want here, but that's ultimately what we're going to do. If we have a minus sign, you move to the right. If we're adding, that's going to move us to the left. Okay. Okay, last one, and then we'll put all these together. So it says, now let's focus on the effect of k on that parent function. So parent function again is this guy. What we're going to do, instead of just having, we're going to use this here, all we're really doing is taking the original function y equals x squared, and we're going to add some number to it. And then we're going to see what happens with that. So now come down here. We know what the original one looks like, y equals x squared. And our new equation is just going to be y equals x squared plus whatever the k is. Notice how now it's after our squared term. It's not inside with the x, it's behind it all. So we're just adding it on at the end. So what this first equation would now look like would be still x squared. And then all we're going to do is add whatever k value I gave you, which in this case is going to be a 1. So we widened it, we shrunk it, we moved it left, we moved it right. We don't have a whole lot of options for what could happen to this one. So, oops, don't read my email, sorry, it's the wrong thing to show. So you could probably guess a little bit what this is going to do. So again, kind of just in your head, take a guess, and then we'll see if you're right in a minute. All right, so we would do now x squared, and then we're going to add 1, and then see if this does what you think it would have done. It's the original, the parent graph. You got to zoom in a little bit. It's hard to kind of see there. But remember how we added a 1? What did this do? What did the red graph do as compared to the blue one, Cam? Good. And how many did it look like it moved up? It is a 1. It's really small. I wish I could blow this up. I don't think I can. I tried to touch my screen and blow it up, and it's not letting me. But yeah, it gets moved up 1. So if I do, what's the next one on your page right now? Can you tell me, Cam? What's the next k value I gave you? 3. All right, so this will be a little more obvious. So if I do, yeah. Would the vertex be 0, 1, or would 1, 0? Yeah, that's now 0, 1. And the black one now is a vertex of 0, 3. Okay, so that k value, so let's get this down now. What this one did is we'll still use the word shift that Cam used earlier, shifts up 1 now. So our vertex, the original parent, went through 0, 0. And then as Cam said, now we're at 0, 1. And then I gave you the 3, so it's a little bit easier to see. This would be x squared plus a 3. And then you would have saw on the calculator this shifts us up 3. So the original vertex goes from 0, 0 to now 0, 3. The 7, no real need to fill that out, or at least no need for us to graph it in order to fill this out. This would shift us up 7. The original vertex of 0, 0 is now moved to 0, 7. And then again, smart group here, write the equation for this, and then just write down what you think is going to happen if our k is a negative 2. And I'm pretty sure all 26 people sitting in here right now will get this right. So just write down what you think. All right, Vicky, don't let me down, Vicky. What'd you write down? Good. So now if it's a negative k, that's going to shift us down, and in this case 2. So that vertex that was originally at 0, 0 is now going to be 0, negative 2. The next one, similar, x squared plus your k, which is a negative 4. If that k is a negative, we're going to be shifting down, and in this case, a 4. So our 0, 0, that was original, is now getting moved to 0, negative 4. So now, recognize this. When we get this plus a negative, all right, adding a negative really is just a minus sign. So same here, this plus a negative really just turns into a minus sign. So keep these straight now, because the previous one, this is the one thing to just keep straight. When we're a negative sign up here, that moves us to the right. That's what we found up here. And when it's a positive sign, that's moving us to the left. So that one's kind of the opposite maybe of what you would think. Adding actually moves us to the left, subtracting moves us to the right. When we're down here, if we add, that's moving us up. That's probably what you would actually anticipate happening. It's a little more intuitive. If I added, we move up. If we add, we move up. But if we have a minus sign at the end, we're subtracting a number, that's going to take us down. All right, so we can write that here, I suppose. If k is greater than 0, you're going to move up. And if k is less than 0, it's going to move our parabola down. My hope is all of those taken individually are really, really easy. We're thinking this is easy stuff. What we just want to be careful of is now number 5. So I still see people looking at this writing, so I'm going to wait a minute. If you look at your number 5 now, they're all kind of thrown together. And we want to see if we can keep all of these things straight. All right, so here I go. I'm going to move this. Let me know if I can't. We're still getting it. So try 5a. At least the transformations. So it says describe the transformations that would be needed to move this graph. So if we're talking about the original graph, and we do these couple of things to it. We do a -6 on the inside, and then we add 3 on the outside. There should be 2 transformations here. So I'm going to do 2 bullets, and we're going to write down 2 things here. So what did we just do to the original graph? If we subtract 6 on the inside of the parentheses and then add 3 on the back side of the parentheses, and see what we think. See if we know what those 2 things are. Okay, so there should be 2 things. Anybody want to give me one of them that just happened to our parabola? How did this get changed? All right, Bisher, give me one. Good. So he said it's going to go up 3 units. So it's the one that we just did before. Tacking on a +3 at the end will move us up 3. All right, somebody else got the second one. What else happened to this graph? How did we move it, change it, whatever? Nora, go ahead. Say that one more time. You kind of broke up. All right, so she says it shifts left 6 units. All right, do we agree with both of those? I'm seeing conflicting opinions here. Vicky, you said no. Why'd you say no, Vicky? Vicky says it goes right 6 units. So hopefully you're in one of those two camps, either the left camp or the right camp. So when we go here, it's a minus, oops, wrong thing. Notice how this is a minus 6. So let's go back real quick. And this is what I mentioned earlier. This is the one you need to be careful of. When we had a minus sign in here, x minus 2, x minus 3, x minus 3, didn't it move us to the right? And if we had a plus sign, so plus, 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 didn't the plus signs actually mean we got moved to the left? It is the opposite of what you might intuitively think for those. So when we come down here now, which camp do we now want to be in? If this is a minus sign, are we moving left 6 units or right 6 units? Okay, Cam's pointing to the right, people are pointing to the right. Yeah, it's going to go to the right 6, okay? So this one will go right 6. You weren't alone, Nora. A lot of people agreed with you, so no need to feel bad. All right. All right. So now with that, if we went right 6 units and then we go up 3 units, tell me what your vertex is. If the original vertex was 0, 0, so if I graph this original function here, if that vertex is 0, 0, and we went right 6 and up 3, where is our vertex now? Does everybody else's chat flash? Can you all see that, what Bisher wrote? All right, do we agree with Bisher? All right, good. That went right 6, so we went from 0 right to 6, and then if we were at a y value of 0, we went up 3. We now have a vertex of 3. We haven't talked about this today, the direction. So yesterday we dealt with some that opened upwards and some that opened downwards. The number in front of all of this is a 1. And what we look to determine if we went up or down is if it's positive or negative. So since this 1 is a positive 1, did that mean we went up or down? Yeah. All right, people pointing up. That means we're going to go open upwards. Axis of symmetry. We talked about it yesterday. So let me draw a quick sketch of this real quick so we understand how to answer this problem. This will be the first time we've actually written the axis of symmetry. So let me draw a graph real quick. So what we just said is our graph is now over here at 6, 3. It's a parabola that opens upwards. So if I put that on the calculator, that's what it's going to look like. The axis of symmetry is that line that cuts this guy right in half. That's what this is standing for, the little AOS, means axis of symmetry. And what I'm asking you now is write the equation for that. Do we all agree that this is really just a line here? It's just a straight up and down line. So you have to remember, and this is one thing that people always get confused, the equation of a vertical line, so let me write that over here, is always x equals some number. That's how you write the equation of a vertical line. So if we're going to write the axis of symmetry, it would have to be the line x equals, and what we need to know is what number does our x have to equal? Well, if you look at this vertical line, here comes our vertical line, here comes our axis of symmetry. What x value does this vertical line pass through? So here it is, right? Here is our y-axis. Here is our x-axis. So if I draw in the vertical line that cuts this parabola directly in half, aren't we passing through the x value of 6? So the equation of this vertical line would have to be x equals 6. So when I ask for the axis of symmetry, it's the equation of that line. These two, I'm going to give you a minute. Do these. You did a lot of this last year. We reviewed it a little bit last chapter, a little bit yesterday. Tell me what you think the domain and range is. Jenna. Calling on you, Jenna, because I just know you're going to get this right. So Jenna, what do you think for our domain? Say that again. Ooh, that's the harder one. Okay, I like that. All right, give me the range, Jenna. What do you think? Do we agree with that as our range? All right, good. That's why I picked on Jenna. I knew she'd get that right. Our lowest y value is 3, and we go up forever. It's a bracket because we do hit that y value of 3. All right, good. All right, the domain then, crossing my fingers, left and right. I'll go with Nick. What do you think, Nick? Good, Nick. Thank you. Negative infinity, positive. You go left forever, we go right forever. Okay? Awesome. Good. All right. Last one today, and then we'll probably finish the rest of these tomorrow. At that point, hopefully we have it all down. We can do homework on it. So last one. See if we can. I'm going to tell you that you should now write 3 things happen that we should write down for our transformations here. So if we again focus on this as our original, the one up here, this x squared, that's our original. What 3 things did we change in the original graph by looking at this equation? So we should now have 3 different things we can write down. All right, so write those 3 things down. How did we change the original in 3 different ways? Just a second, Cam. I'll give you the first one. Give me a second here so people can write a couple things down before we give answers. Okay, go ahead, Cam. Give me one of them. What's one thing that we did to the original now that's different?
We're opening downwards.
Good.
Instead of upwards.
This is now going to open downwards versus the original one opening upwards. Good. So that one opens downwards. All right, I'm going to go back to you, Nora. So this right here, Nora, because now I know you're going to get this one right. What happens if we have an x plus a2 there? What's that going to do to our graph? Good. So that one's now going to shift left 2. The plus 2 actually means we go left 2. And then, Michael, what's the last thing that happens with this graph?
The last thing that happens is I put it down 5 units.
Good. It moves down 5 units because of the minus 5 hanging out at the end. All right, good. So then from there, tell me what our vertex is. So if you haven't done that already, if we started at 0, 0, and then these are the shifts that we made, left 2, down 5. Now where does our parabola land? Where does the vertex land anyway? Oh. All right. Do you think you have it, Michael? That's fine. Go ahead.
Oh, okay. I think it is -2 and -5.
All right. Do we agree with Michael? Good. Left 2 means we were at 0, and if I go left 2, now I'm at a -2. And if my y was a 0 and I go down 5, now I'm at a -5. Okay, good. Very good. We've already done this one. Cam told us this opens downwards. And so that we already know. I'm going to draw a quick sketch again, just so we're clear. Eventually, you don't necessarily have to do this. But if I come over here to left 2, so -2, maybe I didn't draw this particularly good, -5, and we now open downwards, think about the vertical line that's now cutting this in half. So here's this vertical line that cuts this in half. The axis of symmetry is a vertical line, so it's always going to be x equals some number. It has to be. That's the only way to write the equation of a vertical line. And as we split this parabola in half, what x value do we cut through? Whatever that is what you're going to say x equals. Cam, that's what? Good. So it's got to be the vertical line x equals a -2. Our domain, I think, is the nice one. We're going to go left and right forever. So -infinity to infinity. The range, last one here, take a second, write down what you think that range is going to be. Remember, it's always smallest to largest. So when you write this one, I think this might be the first time we've really had to do this. Make sure when you set up your parentheses or your brackets, that this is the smaller number, this is the bigger number. All right, we're always going in this direction. Because it kind of anticipates something that some of us are going to do right now. Start with the small number on the left, bigger on the right. All right, anybody confident with this one? Is that a hand up, Nick? It's sort of like, all right, go ahead, Nick, what do you got? So -5 bracket to positive. Okay, does this go up forever? We may have to rush because you probably just heard the bell ring. So, yeah, so we're going down forever, right? So what we want to start with, I'm going to go ahead and give you guys this, sorry, just because we're running out of time. We're out of time, actually. We start at a -infinity, right? That's the smallest y value that we would ever hit. Just get smaller and smaller. The biggest y value, notice how that's a max. We started kind of calling our max value yesterday. We recalled that from last year. The largest y value, what is that? A -5. See how our vertex is right here at this -5? And then we would put a bracket. So you're right with the bracket on a -5, Nick. That's good. But we want to go downwards forever. All right, so that would be our range. We can hit on that a little bit tomorrow. That's kind of rushed a little. So tomorrow, we'll knock out the rest of these. Hopefully by the end of the day tomorrow, you see another, I think there's another 4 or so. You'll be pretty good. I can give you some homework and you'll be all set. Okay? All right, we're late. Go off the 3rd period. Enjoy your day. All right, we'll see everybody tomorrow. All right, good job. See you guys.